We visited. We walked around, planted a flag, and then we came home. But NASA's new Artemis program, it's a completely different playbook. It's not about visiting anymore. It's about staying. So let's get into how they're planning to build the very first human outpost on another world. It's kind of wild when you think about it. After the mind-blowing success of the Apollo missions, humanity just stopped going to the moon. For 50 years, we went from making giant leaps to taking a half-century pause, and it's a mystery that has baffled people ever since. And that really is the multi-billion-dollar question, isn't it? If we couldn't make it stick back then, why are we so sure we can do it now? Well, the answer isn't just one single thing. It's more like a perfect storm of forces, all converging at once, turning this old sci-fi dream into a very real, achievable plan. To really get the plan, you first have to get the timing. What is it about this particular moment, right now, that makes it all possible? It all boils down to these three major drivers. First, the tech is finally there. I mean, we can now solve problems that were pure science fiction in the 1970s. Second, the cost has absolutely plummeted thanks to private companies like SpaceX. Getting to space is just dramatically cheaper. And third, let's be honest, there's a new space race heating up. China has its sights set on the exact same piece of lunar real estate. You know the saying, location, location, location? Well, that's maybe 1,000 times more true when you're building on the moon. And where NASA decided to build is, frankly, one of the most brilliant parts of this whole thing. Okay, so check this out. The lunar South Pole is a place of incredible extremes, a total paradox. You have these deep craters where sunlight has literally never reached. They are some of the coldest places in the entire solar system, cold enough to have trapped frozen water for billions of years. But then, just a few miles away, on the rims of those same craters, you have peaks that are in near constant sunlight. It's the only spot that gives you both water and power right next to each other. And finding that water is an absolute game changer. I mean, it is the most valuable resource on the moon, period, because it's not just for drinking. You can run electricity through it, a process called electrolysis, and split it into oxygen and hydrogen. The oxygen, that's what you breathe, and the hydrogen and oxygen together, that's powerful rocket fuel. It's the key to making a base truly self-sufficient. So, you've picked your spot. The next huge problem to solve is, how do you get everyone and everything there? This is going to require building the first real permanent infrastructure in deep space. The cornerstone of that infrastructure is the Lunar Gateway. The easiest way to think of it is as a small space station orbiting the moon. It's a waypoint, a command post. Astronauts arrive here from Earth, switch over to their lander, and it serves as a communications hub. And crucially, it's also a safe haven, a lifeboat, if anything goes wrong on the surface. It's really the nerve center of the whole operation. So the astronauts' travel itinerary is pretty straightforward. Step 1, you fly from Earth and dock at the gateway. Step 2, you transfer over to your ride down, which is SpaceX's huge Starship lander. And step 3, you make the final descent to a lunar base that has already been prepared for you. And that part is key. The astronauts aren't just going to show up to an empty plot of dust. Oh no, NASA is sending a whole fleet of robotic landers from its commercial partners first. They're going to drop off supplies, equipment, rovers, and construction materials before any humans arrive. Basically, the robots do all the heavy lifting and get the site ready. Okay, we've landed, we're on the surface. Now comes what is maybe the biggest challenge of all. How do you actually survive and, live in one of the harshest environments we know of? The moon is completely exposed. It has no atmosphere to burn up meteors and no magnetic field to deflect cosmic radiation. That means the surface is just constantly being peppered with tiny, bullet-fast rocks and soaked in deadly radiation. It's a seriously dangerous place to hang out for a long time. So what's the solution? Well, it's actually pretty elegant, and you don't even have to bring it from Earth. The solution is the moon's own dirt, the stuff we call regolith. The plan is to just pile a few meters of it on top of the habitats. Turns out, a thick layer of moon dust is an incredibly good shield against both radiation and impacts. All right, next survival problem, power. Even at the sunny South Pole, you still have to deal with the lunar night, which lasts for 2 solid weeks. Your solar panels are useless. So how do you keep the lights on and the life support humming? The answer is to go nuclear. NASA's been developing a small, compact fission reactor. And when I say small, I mean it's about the size of a garbage can. but it can provide a steady, reliable stream of power for a decade. It's the bedrock, the baseline energy source that guarantees the base never, ever goes dark. All these ideas, using the ice for water, using the soil for protection, they all fall under this one core philosophy called ISRU. It stands for In Situ Resource Utilization, which is just a fancy way of saying living off the land. And probably the most exciting example is the plan to use robots to 3D print structures, like landing pads and shelters, using that lunar regolith as the ink. And that's the whole point, right? The end goal is to be as self-sufficient as possible. You mine your own water from the ice, you make your own air from that water, and eventually you'll grow a good chunk of your own food in hydroponic farms right there. Every little thing you can make on site is one less thing you have to launch from Earth. So that's the how. It's an incredible feat of engineering, but it all leads to a much bigger question. Why? Why are we doing all this? Why does building a base on the moon actually matter? Well, first, let's be totally clear, this is not going to be easy. There are massive risks. That lunar dust, for example, it's like microscopic shards of glass. It gets into everything, tears up equipment, and is a major health hazard. We also still don't know the full story of what low gravity does to the human body over years. And of course, gigantic programs like this are always vulnerable to budget cuts and delays. These are huge, serious hurdles. But the reason we take on those risks is because the moon base isn't the final destination. The moon is the training ground. It's the dress rehearsal. It's where we learn all the hard lessons before we take on the main event, sending humans to Mars. And the payoff for getting this right is enormous. We're going to develop new technologies in things like robotics, energy, and life support that will have real applications back here on Earth. It will unlock a whole new era of science. But most importantly, it's where we will test and prove every single piece of equipment we need to finally become a multiplanetary species and get to Mars. It's almost 240,000 miles away. It feels like an immense distance, but in the vastness of space, it's really just our front porch. This isn't just another mission. This is the first permanent extension of humanity beyond the boundaries of our homeworld. And that really leaves you with a final, fascinating thought to chew on. For all of human history, for every person who has ever lived, we've had just one address, planet Earth. This whole project is the very beginning of changing that. And it makes you wonder, what happens when Earthling is no longer our only identity?